Gravitational waves are ripples in space-time caused by the motion of very heavy objects in very rapid motion. Einstein described gravity as the curvature of space-time and predicted the existence of these very ripples. So gravitational waves are Einstein's cosmic messengers because they bring us messages from the universe, from sources of gravitational waves such as these binaries of dark, massive black holes, or possibly from the very beginning of the universe, from the Big Bang, in the form of a relic radiation of gravitational waves. Andrea has been composing music to scientific themes for a long time. And for a long time, I've been thinking about an art project or a music project about my scientific subject of research. But we had very different ideas going into this. I actually thought that it would be possible to do something like take the formulas, the mathematical formulas of general relativity or gravitational waves, show them to Andrea, and he would write some, very conceptual music that would formally echo the equations and the sounds and the waveforms of gravitational waves. Instead, Andrea showed me that you really need to be looking for emotions when you're composing music and when you're doing art. And so he went looking for what could be the emotions in this show. Perhaps the main emotion in this show is awe of how strange and beautiful the universe is, and how much we can see of it, how far we can see into the universe. The last chapter in the show is about this incredibly violent and spectacular event, which is the merger first of two galaxies in the universe, and then of the two black holes that reside at the center of the two galaxies. These black holes found each other, they form a binary, they start spiraling together, losing energy to gravitational waves, and at the end they merge into a single final black hole, emitting lots of gravitational waves and really perturbing and distorting space-time around them in a violent and spectacular way.
So LIGO is a world-leading effort to measure the effects of gravitational waves that come from very energetic events in the universe, things like colliding black holes. And the effects of these things, by the time they reach the surface of the Earth, are extremely tiny. So LIGO is just a massive challenge of experimental physics and precise measurement. It's a project that now involves almost 1,000 scientists around the world, instruments that are miles in size. We have these instruments located in various places around the country, around the United States. LIGO is not a telescope in the traditional sense. It doesn't look at light waves or X-rays or gamma rays or things of that sort. And so you don't have a tube with lenses pointing up into the heavens. What we have is an instrument that is L-shaped, that responds to actual stretching and compressing of the very structure of space. So we are looking at the effect of gravitational waves on distances between objects on the Earth's surface. LIGO is a device that uses laser light to make these precise measurements. And the lasers we use have to be just incredibly stable. That is, they have to give their light in a very constant way, all at the same color, never changing. Because without this stability, LIGO would be impossible. LIGO involves very, very special mirrors that have special coatings on them, so they reflect 99.99% of the light. Very little of the light is absorbed in the mirrors or passes through. It's all reflected, and that's very important for LIGO to work. The surface of the mirrors is so precise that it's accurate to almost better than the size of an atom in terms of how the shape we like and the shape the mirrors really are. The mirrors look transparent because the light from the lasers that bounces off the mirrors is not of the color the human eye can see. It's infrared light. So these mirrors reflect infrared light, but they don't reflect the normal light that our eyes see. We need a vacuum because the laser light can't bounce off any molecules of air as it goes between the mirrors. LIGO's vacuum arms are these tubes that are 4 feet in diameter and 2.5 miles long. So imagine the volume of 10 747 airliners with the vacuum so good that it is 1 trillionth of atmospheric pressure. When LIGO is operating, it produces large amounts of data, information about the environment in which the instruments sit, hopefully information about gravitational waves. And this data all must be stored, collated, analyzed, and so on. And so we have massive numbers of computers to allow us to sort through all of this data, to look for the pattern of gravitational waves, to look for disturbances in the environment that might fool us and account for that. There's a beautiful control room where a number of people sit there, and what they do is they monitor the functioning of LIGO. It's a little bit like the control room that you see that NASA has for space flights. The people there watching everything, and their job is to recognize problems and fix them. LIGO has 2 important goals. The first is to measure and discover gravitational waves. That's what LIGO was built for, and that will be a Nobel Prize-winning discovery. But after that, what we want to do is use our ability to measure gravitational waves to begin a whole new form of astronomy, to use the gravitational waves to actually understand the sources out in the cosmos that's causing them. So we'll be looking for things like supernovae, exploding stars, black holes or neutron stars, pairs of massive objects that spiral together to form a black hole, gravitational waves from those. Looking for gravitational waves that come from the very beginning of the universe. There's a whole range of potential sources of gravitational waves out in the cosmos that we hope someday to see.
Specifically for this project, most of the inspiration came from images. Of course, the creative feeling has to be connected to the rhythm of the images and the images as well as being edited on the rhythm of the music. I'm using 2 different kinds of instruments. I'm using percussion, which is a very primitive form of expression, and I mixed with the most sophisticated form of musical expression, which is electronic music. And the mixture between the gongs and the sound coming from the keyboard and the drums makes a blend that is not primitive, is not futuristic, is not contemporary. It's a span, is a time warp. Mixture, really like a gravitational wave, distorting space and time. Music is a highly creative form of science, I think. Music systems come from mathematical kind of calculation. Especially the music that I'm writing that is related to a repetition of patterns and building up. There is some kind of scientific approach to that.
I would say that most scientists love art very much and know a lot about art. In the way that we do science, we try to find the right equations, we try to design the best possible experiments. There's really an aesthetics of it. There's really looking for the simplest, most beautiful way to do things that is art. I rejoice in the fact that elegance and beauty should be a part of investigating truth.
Building these huge scientific instruments, clearly involves a lot of creative people, and there's different kinds of creativity. There are people who have the basic intellectual and scientific ideas and work and in some sense do creative mathematics at times to explore what those ideas mean. There are people who are very creative about designing things, about understanding how to build something that will do something that's never been done before. Scientists and engineers do that. Honestly, there are people who are creative in dealing with people, in bringing all these people together, getting them to work together. I guess for me, of all these kind of creativities and these big science projects, that's more of an art than the others. It involves more of the human dimension. So personally, I really enjoyed the music and I enjoyed the performance. I thought the show was wonderful. But it's even more important to me that the show really does succeed in communicating to people in the audience something about the way science is inspired and the excitement of doing science and the thread of some of these ideas throughout history.